Hello kids. So today we are going to do the last exercise of this chapter 3.12. Let's start with the first question. It says there is one supercell that is the number greater than all its neighbors in this grid, and this is marked in green. Why this is a supercell? Because it is greater than the top cell, bottom cell, the right cell and the left cell. So that's why it's a supercell and it is marked in green for us. Now if you exchange two digits of one of the numbers, so if here in this whole grid, if we swap any two numbers, swap means if we change the place of any two digits, then this grid will have four supercells. Okay, so let us try to figure out that which digits we have to swap here. So kids, what I'll do here is I will focus on this supercell and I will change the place of 6 with 1. So the new number, this number will be changed and it will become 1, 2, 8, 7 and 6. So you understand how what I have done? I have swapped, that is exchanged the places of these two digits, 6 with 1. So 1 has come here and 6 has moved here. And the new number with us is 12,876. So let us see that if we have this number now, do we get 4 supercells in the grid as it is asked in the question? Okay, so let's start here. So since this number, it is neighbor to this cell first. So I will focus on this cell first. This cell is greater than 12,000 because 39 is greater than 12. Okay, so 39,000 is greater than 12,000. This is greater than this number. Similarly, 39,000 is greater than 16,000 and 39,000 is also greater than 29,000. This is in 29,000 series, right? So that means this cell will become a supercell now. I will highlight the supercell in yellow. Okay, I am highlighting this new supercell with us in yellow here. Okay, so I hope you understood how, because this cell is greater than all the neighboring cells, right? Now let us move to this cell, because this cell is also neighbor to the changed cell. Okay, here we can see this number is in 23,000 series. Okay, so 23,000 series is greater than 16,000 and it is also greater than 19,000 and it is also greater than 12,000, the changed number. So that means it also become a supercell. Why? Because it is greater than all the three neighboring cells. So I'm also highlighting this new supercell in yellow now. Next, what we have is this supercell is also neighbor to this. So let us see if it also become a supercell. Here we have 50,000 series. This 50,000 is greater than 12,000. This 50,000 is greater than 19,000 series. It is greater than 38,000 series. That means this is also a supercell. So what we will do, we will also highlight this as a supercell here. So now we have 3 supercells and we need one last supercell. So let us focus on this cell because again this is neighbor to this cell. Okay. So here 45,000 is greater than 12,000, is greater than 29,000 and is greater than 38,000 also. So that means this 45,000 cell also become a supercell. So now we have this 4 supercell, and how we have got it? We have swapped the digits of this given number. Which two digits? The 6 with 1, and we have got a new number which is less than its neighboring cell. Okay, so I hope this is clear, kids. And now we will move to second question. How many rounds does your year of birth take to reach the Kaprekar constant? So we know the Kaprekar constant is 6174. And kids, you know your year of birth. So let's say if your year of birth is 2010 or 2011, what we have to do? We have to take the highest, the lowest number. We have to find the difference. If the difference is equal to Kaprekar constant, then that's okay. If it is not, then we have to again take the greatest and the smallest number from the difference. So this question I leave to you. You have to do it as per your year of birth. Okay. Now, let us move to question number 3. We are the group of 5-digit numbers between 35,000 and 75,000. Okay, so there are 5-digit numbers. There is a group of 5-digit numbers between these two. This is the range given to us, such that all of our digits are odd. So it says that all the digits are odd. Who is the largest number in our group? Who is the smallest number in our group? Who among us is the closest to 50,000? So kids, let's try to solve this question. Answer number 3. First of all, what it is saying is that there is a group of 5-digit numbers. So there are certain 5-digit number group, and those 5-digit numbers, they are in between this range. These 5-digit number, they lie between these two. This is the range. It is greater than 35,000 and less than 75,000. And these numbers are such that all the digits are odd, and we have to find that among this group, which is the largest number, smallest number, and which is closest to 50,000. So first of all, let us take that what are the odd digits with us. They are 1, 3, 5, 7, 9. These are the 5 odd numbers with us, and we know that. Now using these odd numbers, we have to create the 5-digit numbers such that they lie in this range. Okay, that is the first criteria. All the numbers should be odd. The number should lie in this range. They should be 5-digit number, and then the first thing we have to do is who is the largest number in our group. We have to see which is the largest number in the group. So let's see. First of all, among 1, 3, 5, 7 and 9, we know that 9 is the largest number. Okay, but can we make a 5-digit number starting with 9 here? We cannot. Why? Because we have a range defined. We have to consider this range 35,000 to 75,000. So I cannot make any number, 5-digit number which starts with 9. Okay, because then that 5-digit number will be out of the range for us. It will be greater than 75,000. So what we will do, we will pick the next highest number to find the largest number. What we are doing here, we are finding the largest number of the group. Okay. So the first digit I will take here is 7. The next digit, if I will take 9, because I have to form the largest number, then it will be 79,000 something, which will again be out of this range. So I cannot take 9 again. So the next number which I can take here is 5. 75. So kids, if I take 75 here and then any other number, again it will fall out of my range. So that means I cannot take 5, I cannot take 9. I cannot take both of these number. I cannot repeat 7 again because again it will fall out of the range. If I'll take 9, it will be 79,000 out of the range, 77,000 out of the range, 75,000 something out of the range. So what I can take is 3, because 73,000 something will be less than 75,000 but still on the higher side. Okay, so now I can take 73 and the rest 3 numbers I have to fill. So kids, rest 3 numbers should be odd numbers and they should make it as a largest number. So what I'll do, I will simply write 9 3 times. Okay, so I hope this is clear. What I have done, we have to find the largest number falling in this range. So what I did, I cannot start the number with 9. I cannot make a 5-digit number starting with 9 because it will go out of 75,000, which is not permitted as per our question. So I'm starting the number from 7. Second number which I have to take, I cannot take 9 because 79,000 will be greater than this. I cannot take 7 because 77,000 will be greater than this. I cannot take 75 because 75,000 something will be greater than 75,000. So I'm taking 73. Now the rest three numbers should be such that it should make it as a largest number, and these numbers should be odd and highest. So that's why we are taking 9 here. So this is the largest number in the group. Okay. Now, similarly, we have to find the smallest number in the group. So kids, we have to find the smallest number and it should be greater than 35,000. So let us do one thing quickly. What we can do, this is easy. We can take 35 first of all. First two numbers will be 35 only. Okay, because if I take 31, it will be less than this. If I take 33, it will be less than this. If I take 35, so that's why I'm taking 35. And again, I have to fill in these numbers in a way using these odd numbers such that it should make a smallest number of the group. So I will fill it with 1. So 35,111 is the smallest number of the group. Okay, I hope this is also clear. And now, who among us is closest to 50,000? So that means we have to make another odd number which is closest to 50,000. And it should have what? It should have all odd numbers. So, number closest to 50,000 is 5 first. Okay, then the next number which will be closest to 50,000 here will be start with 1. So this is 51,111, right? This will be closest here because if I will take 3, this will be in 300 series. So lowest will be 100 series. Again, 111 is the answer to this. So I hope this is clear. This is a very good question, kids. Next, estimate the number of holidays you get in a year, including weekend, festival, and vacation. Then try to get exact number and see how you estimate it. So kids, this is the question of estimation which I am giving you. I am just marking the questions in homework. This is homework, easy. I have given you hint. Here also I am giving you hint. We have 12, we know that we have 12 months. You have to see that which month you have vacation. You have to also cut out the weekends, that is Saturdays and Sundays. Also, you have to consider the festivals and estimate. Then you have to make the estimation of the exact number. Okay. So, this is homework for you guys. Next is estimate the number of liters. So that is how much liter of a liquid can come in a mug, a bucket, or an overhead tank can hold. Sorry, it can hold. So this is easy, kids. I am just writing the answer here. A mug is small or big. So depending upon it, since we are talking in liters and not milliliters here, so the least a mug can hold is 1 liter. Okay, it can hold 1 liter. A bucket, it can be of any size, approximately 15 to 20 liters. 15 to 20 liters. And overhead tank, again, it comes in different size. It can hold 10,000 liters or it can hold 20,000 liters, 25,000. Anything you can take. Okay. Next is write a answer number 6. I will solve here. Write one 5-digit number and two 3-digit numbers such that their sum is this. Okay, so we are given with the number 18,670 and we need one 5-digit number and two 3-digit number. Which one combined give us this? So kids, this is very easy. If you look at this number, answer lies in this only. So the first 5-digit number we can have here is, I can straight away write 18,000. Okay, that is the first 5-digit number. and now we need two 3-digit number. So first 3-digit number I can take. So when I subtract 18,000 from 18,670, I am left with 670, 670. And now I need two 3-digit numbers. So what I can do is I can break it into two parts. How? I can take first number as 370 and I can take the second 3-digit number as 300. So when I'll add all this, I will get this number. Let's try 0 and this one is 7, 6, 18. So what we did, 5-digit number straight away we can take 18,000 and if we subtract we will get 670. Now this 670 I have to divide it into two parts. Anyways you can do this. I have taken 370 and 300. You can also take it as 350 and 320. So you can do it in any form. Okay. Now next is question number 7. Wait. Yeah. So question number 7 is there. It says, choose a number between 210 and 390 and create a number pattern similar to those shown in section 3.9 that will sum up to this number. So kids, we have done those number patterns where we had squares, where we added the dot in square, the number in squares, the hexagons and the diamonds. Similar kind of pattern we have to make for any number between this 210 and 390. Okay, so let's try with 240. So what I have done, I have taken 240. Now before I can draw anything, let me try to break this 240 into different parts. So kids, how we will do? We know we can write 240 as 20 plus 40, right? And this 200, I can write it as 50 multiplied by 4. And this particular 40, I can write this as 10 multiplied by 4, right? So now let me try to draw this. 10 multiplied by 4. So I am taking squares and in squares I am writing 10, 1, 2, 3 and 4. And then for 50 I am taking here 4, 1, 2, 3 and 4. So this is 50, 50, 50 and 50. And if you will try to solve this, this will give me 240 numbers. So I hope this is clear. Since we had to take any number in this series, in this range, so I took 240. 240, I have written it as 240. I have breaked it into two parts, this one. And then further, I have broken 200 into 50 into 4 and 40 into 10 into 4. And this is the pattern which is required. Okay. So this is done. Now coming to question number 8. I'm writing this here. Recall the sequence of powers of 2 from chapter 1, table 1. So what is sequence of power of 2, kids? Sequence of powers of 2. And what is this? It was 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4 and so on. And it gave us 1, 2, 4, 8, 16, 32, 64 and so on, right? It was 2 raised to the power 5 and 6 and so on. Okay, so this was the sequence of power of 2. Now, why is the Collat's conjecture correct for all the starting numbers in this sequence? So let us take a starting number 8 here and try to find out the Collat's conjecture. So this is Collat's conjecture of 8. 8 is a even number. So for even number, we will divide it in by 2. This 4 is even divided by 2. 2 is even divided by 2 and then 1. So when we took 8, we are getting 1. Now let us try to take 32. So for 32, 16. 16 is 8 and then again same series 4, 2 and 1. So if we are taking any number here, we are reaching to 1, which is as per Collat's conjecture. So kids, why this is true? Why it is happening? So basically what is happening here is that whenever we are dividing any number by 2, we are reducing the power and making it close to 1. Okay, so I'm writing it here. Power reduces with each power reduces with each division by 2 and makes it near to 1. So we understood what it means. It means that whenever I'm dividing it by 2, its power is reducing. Earlier it was 2 to the power 3, 2 to the power 2, 2 raised to the power 1 and 2 raised to the power 0. So it is reducing each time. The power is reducing each time I am dividing it by 2, and which is making it closer to 1. So that's why this is happening. Okay. Next is check if the Collat's conjecture holds for the true for the starting number 100. Now we have to check this with 100. So kids, I am leaving this as a homework to you, and this one is homework, and this marks the end of this chapter from NCERT book. So in the next class, I will pick up the exercises from R.S. Aggarwal of this chapter, and I will see you all in the next class now.